fellas. This month's session should have a little more bounce to it than usual. We're going to cover the subject of shock absorbers. Shock absorbers are probably one of the most misunderstood parts of the suspension system. Nick is going to give Fred a thorough lesson in the theory of operation, testing, and servicing of shock absorbers. I think Nick's about ready to start. So why don't we join them and maybe learn a thing or two ourselves?
The shock absorber is really not a complicated part, Fred. It's just that most people don't really understand what the shock absorber does, how it works, and how to test and service it. Hi, Tech. I'm glad you came along. If you're up to your usual stuff, I'm sure I won't leave anything out. And I'm sure you've got your ready supply of warnings and helpful hints.
That's why I'm here, Nick. So you can continue with Fred anytime you're ready.
Okay, Tech. I think the first thing to clear up is some of the wrong ideas a lot of people have about shock absorbers. For all practical purposes, the shock absorber doesn't live up to its name. It really doesn't absorb shock at all. On the other hand, some owners think that if a shock absorber is damaged or has lost its fluid, the car will sag. We all know that the shock absorber does not support the weight of the body. This is done by the rear springs and front torsion bars. Although some of the minor road shock is absorbed by the tires, the suspension system does the main job of absorbing road shock as the wheels roll over bumps or into holes in the road. Basically, there are two spring movements that occur when the wheels hit any irregularities in the road surface. If the wheel moves upward toward the body, it's called jounce. When the wheel moves down, away from the body, it's referred to as rebound. Jounce and rebound occur whenever enough force takes effect to flex the spring. The spring continues to flex in opposite directions until the force is completely dissipated. If a large enough load is applied to the car suspension, the spring reaction is transmitted to the body. Body movement is, in most cases, opposite of wheel and spring movement. When this happens, the weight of the body then adds to the spring action and makes bouncing even more difficult to control. Controlling suspension and body movement is the real job of the shock absorber. The shock controls the jounce and rebound of the car's suspension and body. It acts as a hydraulic snubber to dampen spring action and retard body movement. Today's suspension systems are designed with a low spring rate to give what is generally referred to as a soft ride. A low spring rate simply means that it doesn't require much of a load to flex the spring. On smooth pavement, today's standard springs are flexible enough to allow the wheels to follow slight irregularities without transmitting their movement to the car body as a road shock or harsh ride.
Well, with a low spring rate, won't the car bottom if you run over a good-sized bump or a chuck hole?
You're right, Fred. And that's why shock absorbers are so important to today's suspension system. The shock absorber must not only provide snubbing control, but must also vary the amount of control to different car speeds and road conditions. A modern piston-type hydraulic shock absorber is designed to automatically provide the right amount of resistance for all normal road conditions. For example, a smooth road surface only requires slight snubbing action by the shocks. Therefore, on smooth pavement, suspension and body movement is slight. Nevertheless, it is necessary. Obviously, rougher road surfaces require stronger snubbing action by the shocks to keep body and suspension movement under control. The shock absorbers must automatically increase their resistance many times more to cushion or dampen the increased spring action.
You know, I can't understand how the shock can adjust the amount of resistance or the snubbing action to the amount of spring action.
I was just about to show you exactly what happens inside a shock absorber, but I'll answer your question first, and then you can see how it's done. A shock absorber is basically a piston within a cylinder filled with hydraulic fluid. The action of the piston forcing fluid through a restricted passage or valve achieves the damping effect. The damping effect is caused by the back pressure built up as the fluid is forced through a small opening. The pressure builds as the velocity or speed of the piston increases. The best comparison of this is a hand-operated bug sprayer. If you pump the handle slowly, there's very little resistance. On the other hand, if you pump the handle a number of fast strokes, you'll be able to notice a considerable increase in resistance. The shock absorber functions pretty much the same way. The faster the piston moves, the more snubbing action you get from built-up pressure or resistance. Before we go any further, let's take a look and see if I still have that cutaway shock absorber. We'll start with the body of the shock. The body of this type of shock absorber usually consists of 3 concentric steel tubes. The innermost is the pressure tube where the actual snubbing action is performed. Incidentally, the inside diameter of the pressure tube is the same as the size designation of the shock. The second one is the reservoir tube, which holds a supply of fluid, and the outer one is a shield to protect the extended piston rod. In some cases where the piston rod extends into a protective housing, a shield is not attached to the shock. This usually occurs on front suspension systems rather than rear. At the bottom of the shock is a ring or mounting eye welded to the reservoir tube for connecting the shock to the rear spring clamp or lower control arm on the front. The top of the shock can have either a mounting eye or a threaded stud. Internally, of course, there's the piston rod and piston. Piston movement is what forces the fluid through the valves to produce the snubbing or damping action. There's an oil seal above the rod guide at the top of the shock. The rod guide prevents leakage from the pressure tube and maintains pressure within it. The inside of the seal has 3 wiping edges, which prevent loss of fluid as the rod is extended. Between the wipers are spaces that hold enough fluid to keep the rod lubricated. On the compression stroke, the seal pumps the fluid from between the wipers into the pressure tubes.
When a shock is leaking fluid, does it mean that the seal is worn out and should be replaced?
A certain amount of seepage is not abnormal, Fred, but it doesn't automatically mean that the shock should be replaced. I'll explain that in more detail later. Right now, let's take a look at what actually causes the snubbing action. There's a valve at the bottom of the pressure tube, which is generally referred to as the base valve. This valve provides about 90% of the control in a jounce condition. Valving within the piston provides the remainder of the control. The base valve provides both high and low velocity jounce control. The base valve varies the amount of control through back pressure alone. The faster the piston travels, the more control you have. If you remember the bug sprayer, you know what I mean. On rebound strokes, it's a little different story. If the fluid flow from the reservoir through the base valve is great enough, the disc lifts to provide a larger orifice. So, at high or low velocity, the base valve doesn't offer any rebound control. Rebound control is accomplished through valving within the piston. However, there are 2 phases of resistance. Low velocity resistance is provided through orifices much the same as the base valve. As the piston velocity increases, a blow-off valve disc is deflected for additional fluid flow through the piston. This prevents the rebound action of the body from becoming too harsh or stiff.
If more resistance is needed to dampen high-velocity motion, why is the blow-off disc used to provide a larger opening? Wouldn't that decrease the resistance?
Now that proves you're paying attention, Fred. I'd better explain that. The pressure does increase naturally as the velocity increases. However, on high-velocity jounce or rebound strokes, the resistance would be so great that the harshness of the ride would be uncomfortable. If a larger orifice were provided for high-velocity shock action, the shock action would be too soft or mushy at low-velocity operation. So, by controlled blow-off, adequate control and comfort are achieved at all times.
I think that by now Fred is pretty well convinced that the shock absorber is pretty important to the car's ride. I think he will agree that today's shock absorbers are designed to handle the job. Most people don't realize this and are too quick to blame the shocks when the car's ride is not what they think it should be. We'll discuss some common service problems right after someone turns the record.
First of all, let's talk about the type of shock absorber problems you're apt to run into. The most common conditions are that shocks are either weak, noisy, or leaking. Virtually all of today's cars are designed to give a soft ride. First of all, because most owners prefer this type of ride, and secondly, improved road conditions allow it. However, if the owner complains of frequent bottoming, the problem may be in the suspension and not the fault of the shocks. Be sure and check the front suspension height. After about 5,000 miles, when new car stiffness and friction have been worked out, the ride of a new car may become noticeably softer. The rate of weak shock complaints is also likely to increase in the springtime, when warmer weather decreases fluid viscosity. Spring Springtime is when you may notice what seems to be abnormal seeping of shock fluid. That doesn't mean that you won't get seepage at any other time, but here's why it's common at that time of the year. A certain amount of fluid seepage is necessary for lubrication, but in winter, the seal gets a little stiffer, and fluid loss will be greater than usual.
Actually, shocks have more fluid than necessary, so a minor loss of fluid won't affect the operation.
How about noisy shock absorbers?
The shock may make some noise if the car has been sitting for some time, especially in the winter. However, a couple of miles of driving should eliminate the noise. If it doesn't, you should replace the shock. But remember, the shock absorber is innocent until proven guilty. When an owner says that he thinks the shocks are bad and the only reason he can give is the ride and handling of the car, eliminate all of the other possible causes before blaming the shocks. The best place to start is the tires. Make sure they're properly inflated and check the treads for flat spots or uneven wear. Uneven tread wear can be the result of improper inflation, incorrect wheel alignment, or unbalanced wheels. The tread wear and the condition which caused it will both affect the ride and handling. Next, check front suspension height and correct it if necessary, so you won't mistake low or uneven suspension for poor shock absorbers when road testing the car. Speaking of road testing, the only sure way to test shock absorbers is by making a thorough ride test. Because the shock absorbers must control a wide range of ride conditions, a complete checkout should cover minimum, intermediate, and maximum control functions.
I've seen a lot of technicians testing the shocks by bouncing the car. Seems to me that would save a lot of time.
About all this test will show up is a shock that is completely shot or noisy. It won't show up a shock that is only partly effective. The reason is the bouncing that you can apply in the shop can only make the shocks work enough to check the least amount of snubbing action. To produce the abrupt suspension and body movements to check the complete controllability of the shock absorber, it's necessary to test drive the car. Of course, a visual inspection is probably the most practical thing to do first. A quick look under the car will show an extremely leaky or damaged shock absorber.
Tell me, do you or don't you replace them in pairs?
The chances of shock absorbers going bad in pairs are few and far between. Except for leakage or physical damage, a shock will last indefinitely. So don't waste your time by replacing a good old shock with a good new one. How about telling us about that road test, Nick?
Okay, Tech. First, pick a route that you can use regularly for all your road tests. Both smooth and rough stretches of pavement are a must to check the wide control range of the shock absorber. If possible, work in a fairly rough railroad crossing. It can be very helpful. Next, test a car that you know has good ride and handling characteristics. By driving the car at different speeds over the test route, you'll know what to expect if you test other cars of the same model. When making a test run, compare the ride with that of your standard car. Shock absorber action over minor bumps such as expansion joints shouldn't be harsh or stiff in comparison. The smooth rolling bumps you may find at bridges, street crossings, or low spots should be controlled equally as well. Driving over a smooth rolling bump is an important test. Good shock absorber action will make the car body level out almost immediately. On the other hand, poor shock absorber action in either the front or rear will cause a pitching motion as you come off the smooth rolling bump.
Don't take a series of this type of bump in rapid succession, and don't take them too fast. If a shock is bad, the pitching motion can lift you off your seat. So remember to fasten your seatbelt. And don't be alarmed if the car bottoms out over a rolling bump. Remember, today's springs aren't designed to absorb that much of a load.
Good point, Tech. Be sure to note and remember the rough spots along the test route. If a car with adequate shock absorber action is able to handle suspension and body movement, then any future car which you test should do as well. Once you establish the fact that the shock control is below standard, you have to determine whether the trouble is front or rear and right or left. The only way to compare the shock absorber action on both sides and at both ends is to make repeated runs over rough pavement to check for excessive hop at each wheel.
You mentioned a train crossing in the test route. What will that prove?
A fairly rough railroad crossing will cause abrupt level changes which call for maximum shock absorber control. Driving straight across the tracks, test the front shocks first, then the rear. A multi-rail crossing is also a good test for suspension strike-through or bottoming. Driving over several sets of tracks can allow violent pitching movement if shock absorber control is poor. Even at low speeds, this movement can cause much the same action as a smooth rolling bump at high speeds. Driving across the rails at an angle will let you test shock absorber action at each wheel. Drive slow enough so that each wheel reacts separately to the rails. You'll need a little experience at this test before you're able to spot a bad shock quickly. If either side has a poor shock absorber, you'll notice that that side has a greater tendency to bounce and will cause a body rolling movement as the car crosses the tracks.
What if you thoroughly road test the car and you're still not sure the shocks are at fault?
If you suspect the shock absorber, but have any doubt about its condition, disconnect it at the bottom and give it an operational check. To check a front shock absorber, the suspension and wheels must hang free. The rear shock absorbers can be disconnected and hand-operated with the suspension either loaded or hanging free. As you compress and extend the shock absorber, you should feel a smooth and consistent resistance to movement. Any soft spots in the movement or overall lack of resistance, except near the end of the stroke, is a good indication that a new shock absorber should be installed. When installing new shock absorbers, always purge the pressure tube so that the shock is not installed on the car in an air-rated condition. Air in the pressure tube can make shock action soft, spongy, or spotty. It's also likely to be noisy, and you'll have the owner back with another complaint. It's pretty easy to purge a shock absorber. Here's how it's done. Hold the shock absorber right side up and extend it all the way. Turn the shock absorber over and compress the shock until it's completely collapsed. Extend and compress the unit several times. I'd say at least a half dozen times. What little, if any, air remains in the fluid will be purged after a short period of operation.
Remember, always extend the shock right side up and compress it upside down. And when you're ready to install the shock absorber, always extend it in the upright position, never in a horizontal or inverted position. If you do, you'll aerate the shock all over again. If you remove a shock absorber and plan on reinstalling it, the first thing to do is to invert the shock and compress it. How about installation, Nick?
Okay, Tech. First, a little warning. Don't ever throw a shock around or get careless and drop it on the floor. The pressure tube could get damaged or the piston rod bent. There's one thing to remember when installing a new shock absorber or reconnecting one after testing. Always be sure to center the mounting bushing and tighten the mounting nut to the correct torque.
It looks to me like that bushing will center itself.
I'd better explain. I meant that the bushing must be centered radially in its normal load position. If not, the bushing life can be shortened considerably. Here's why. The rubber bushing in the shock absorber mounting ring must be able to twist equally in either direction from the normal load position to allow movement between the shock absorber and the part it's connected to. This twisting action is known as wind-up. If the bushing mounting nut is tightened when the car is raised off the wheels, the bushing will wind up in one direction when the wheels and suspension return to the normal load position. This wind-up puts a constant strain on the bushing as well as the piston rod and seal, which can shorten service life considerably. Just a couple of final reminders. Be sure you use the correct bushing and never use any kind of lubricant other than water on rubber bushings before or after they are installed. A lubricated bushing may slip and wear out instead of flexing normally. That's going to have to be the end of the session, Fred, so let's hit the road.
Thanks a million, Nick. I sure learned a lot today.
Well, fellas, that's it for this month's Master Tech session. Before I hit the road, I'll slip in my usual reminder to read your reference book from cover to cover. There are a few things in the reference book that we didn't have time for in the film. See y'all next month for an electrifying session on alternators and regulators.